Recall that statistical power is the probability of detecting an effect in our sample that really exists in the population. I want you to know that definition and also the different factors that impact the size of power. So recall those two curves that we talked about last week. They're here again in this slide in the bottom right. Remember that the blue curve represents the reality under the alternative hypothesis, and the red is the reality under the null hypothesis. And remember, we don't know which reality we're living in. This is just hypothetical. This is for learning to understand the two different possibilities that we have. So remember, the first factor that impacts power is our alpha rate. And remember, our alpha is the type 1 error, and it's the probability of it detecting an effect in our sample that does not exist in the population. And so typically we always make that very tiny. We don't want to commit that error. But remember that we can increase this if the cost of committing a type 2 error is very high. And so in the figure, note what would happen if we moved that alpha over to the right and made it larger. What would happen to power? Power would get larger. Okay, so we would have more of that solid blue space. We would have less of the beta space or the type 2 error, so that would decrease. So take note of that. For the next one is n size, and that one's easy, right? As n increases, power also increases. And especially for finding small effect size, if we have a small effect size in the population and we need to find a tiny effect in our sample, we would need a pretty large sample to do that. Remember, large n gives us the sensitivity to pick up small effect sizes. So we have two factors that impact power that we have control over. We have our alpha, which we can make larger. We just have to justify it when we're turning in the study for publication. And we have our n size, which we sometimes have control over if we have resources to do so. But the effect size in the population is the last thing that affects power, and that we really don't have control over. But if we have a large effect size in the population, a big effect to find, it will be easier to find it. So that means power is increased for our study. If we have this small effect size, we will have diminished power to find that small effect, and we'll need lots of n to detect it. And we'd probably want to raise our alpha as well if we thought it was that small to detect it, and if it was a small but important effect to find. So those are the three things that impact power. Know those. Understand what's going on with these curves. Pull them apart in your mind's eye. Make that effect size larger in the population, and notice what happens to power and to type 2 error. And then squish them together. Make the effect very tiny and such that they're overlapping a lot. And note that it's probably going to be more difficult now to detect an effect because power will be diminished. That blue space, there will be less of it in the case where these two curves overlap significantly. So keep working with it, keep thinking about it. Don't give up, persist through this so that you can have a good idea of each of these different elements and how they impact the probability of us detecting a true effect that really does exist in the population.